Hi everyone, our presentation today is on water filtration and sunscreen pollution. My name is Chloe Shannon.
I'm Jessica.
I'm Rai.
I'm Josie.
And my name is Arnav.
So what is sunscreen pollution? Every time you go to the beach, you apply suntan lotion onto your skin. Well, that same suntan lotion also dissolves into the water and can actually affect the community within the ocean. And very little research has actually been done on this field. Most of it focuses on creating a new eco-friendly sunscreen or limiting tourists to go to a certain part of the beach where they can't harm the sea life. And anyways, today we will be investigating the removal of undesirable chemicals from seawater, and we will be specifically focusing on zinc oxide, which is a key component of sunscreen. So zinc oxide is a nanoparticle that is used in sunscreen, and it works by absorbing UV light, and it protects our skin from harmful UV rays. So although it seems that zinc oxide is actually healthy and protects our skin, it is actually harmful towards coral reefs and animals within the ocean. However, if we focus on how to remove zinc oxide from the water, we might have a solution to this problem and can actually help the ocean. So as you can see in this picture, this image shows a once healthy coral and the after effects of what happened after it has been exposed to sunscreen. Basically what sunscreen does is that it bleaches the coral and it prevents it from being able to provide shelter and nutrients to the animals that live there. And just beyond just coral, all marine life is affected by zinc oxide nanoparticles, and marine life is essential to attracting tourists, and without those animals in the ocean, the economy could be impacted. And some locations have already banned the use of certain chemicals in sunscreen, such as Hawaii, but studies on zinc oxide show that it can too harm sea life.
Okay, so our question is, what is the most effective method of filtration that can separate zinc oxide from the ocean water? So we predict that zeolite A in conjunction with the membrane filter will be the most effective way to separate zinc oxide from the ocean water, because zinc oxide is slightly positive and it is small enough to interact with zeolite and its pores. So zeolite A is a crystalline aluminosilicate nano network that has nanoscaled pores that are slightly negative, so it attracts positive ions, and since zinc oxide is slightly positive, it gets attracted to the zeolite A and interacts with the pores. And then afterwards, we would use a membrane filter, which would filter out zeolite A, which has the zinc oxide attached to it.
Okay, so we broke our experiment down into two parts. The first part of the experiment was we wanted to see if we could even calculate the concentration of zinc oxide in ocean water. And the way that we did this is we prepared lots of vials, some with DI water, which is our pure baseline, and some with ocean water from Santa Monica. We prepared lots of these vials, and the next step we did is we wanted to put measured volumes of sunscreen in each vial, but we had to dissolve the sunscreen first because it was too thick to actually get a good measurement. So we dissolved it in ethanol, and then we added the drops of sunscreen to respective solutions. First, we started out with the 1 through 15 drop, but we realized the absorbance spectrum is too big of a range for this, and we stuck with 0 to 2 drops with increments of 0.2. The last step we did for the calibration curve is we measured the absorbity using a UV spectrophotometer. And the idea behind this is if zinc oxide soaks up or absorbs UV light, then the more zinc oxide in a solution, the more absorption it should have. So this is our data for the pure DI absorption, and it looks pretty similar for ocean, so I just put this graph on. And you can see here that there is a higher amount of absorption around this area, so our max absorption wavelength is 327 nanometers. The next thing you may notice is that the higher concentrations always have a higher absorbance. And if we take the relationship between the concentration and absorption, we get our calibration curves. And our calibration curves are the instruments that allow us to measure the concentration of zinc oxide in ocean water.
Okay, so once we have our water mixed with our zinc oxide, what we did next was we added 1/8 teaspoon of zeolite A, and as shown in this picture here, we filled up in a syringe, filled up with the water, and we got a membrane filter which we put into another vial so we can see the purified water, so we can see like how much did the membrane filter like get out of the water.
Okay. And some people may be thinking, so you can filter zinc oxide out of water, possibly. What about the zeolite? Is that going to harm the sea life or anything? So we took scanning electron microscopes. The first one's actually found online, but the second one is a picture from ocean water that has been filtered with a membrane filter and mixed with zeolites. And the zeolite picture is on a scale of 2 micrometers, and the ocean water is on a scale of 10 micrometers. So you can obviously see that there's nothing that resembles the zeolite picture in the ocean water picture, so it's safe to assume that there is no zeolite left over.
So in this graph here, we're comparing the absorption of filtered DI water to the absorption of unfiltered DI water. So we see that, hold on one sec. So we see that the absorbance of the filtered DI water is significantly less than the absorbance of the unfiltered DI water. So that means there's a decrease after filtration in the absorption of zinc oxide. This also corresponds to a decrease in the concentration of zinc oxide after filtration since, as mentioned previously, concentration is directly proportional to how much UV light the water will absorb. Okay, so ocean water, we see a similar trend where after filtration, the absorption of zinc oxide is significantly less than the absorption of the unfiltered ocean water.
So once we finished our experiment, we figured out that the absorption of the UV rays from the water decreases once we put the membrane filter and the zeolite A. And when we were right when we said that we can get rid of the zinc oxide, as shown in our scanning electron microscope pictures. But since zinc oxide is so small, we don't know if we just took out like zinc oxide by itself or it came with other particles. And if we had like pure zinc oxide, we would have more accurate results compared to the ones we have.
Okay, so this is a graph made based off of water that is straight from the ocean, and this graph shows the maximum absorption of zinc oxide in ocean water. So in the red box, you can see it is really low, and it's essentially nothing. But this just means that the zinc oxide in the ocean is really difficult to detect with our current instrument, which is the UV vis, and because it is not sensitive enough to detect something that is that has a concentration this small. So although it's really dilute, it is still proven to be a really big problem, and we should still find a way to filter out zinc oxide from the ocean.
Okay, so some directions we can take for the future is, as Jessica mentioned, we can increase our sensitivity to smaller quantities of zinc oxide. So the ocean is has a lot of volume of water. So the concentration of zinc oxide would most likely be in the nanomolar range or even the picomolar range. So with our UV vis spectrophotometer, the lowest quantity we could detect was 6 micromolar, which you might think, hey, that's pretty small, but the ocean has much lower concentrations. My bad. Okay, so next thing we can do is we can increase our specificity of filtration to only zinc oxide. So as Rai mentioned earlier, we know we filtered out the sunscreen, but we're not entirely sure if we filtered out only zinc oxide or there's other molecules that could potentially affect the sea life that we're trying to help in this experiment. Last thing I want to talk about is creating a large-scale filter. So in an effort to apply our methods to the real world, we want to create something that can be used for like oceans and like just much more quantities of water. So what that will entail is we have wait, pull that up. All right, thanks. So we have unfiltered water coming in at A, and then B, we would have a mixture of zeolite C, we're approaching the membrane filter. D is the membrane filter, and then the rest is just filtered water coming through.
And with that, we conclude our presentation. We thank you for listening, and we also want to thank Shailene for helping us with our experiment.
Oh, nope, that. I'm sorry, may you repeat? So we measured the absorption by using the UV spectrometer, or spectrophotometer, the UV vis, and we shot a ray of UV light through the solution, and we did it at different concentrations, and it showed, here I'll pull up the absorption graph. It showed like at wavelength 325, you can see with like the 6 micromolar, you can see that the absorption is like 0.1 or something, and then we use some math to calculate the concentration later on. So there's two explanations for that. One is that we blinked for our baseline, we blinked it with DI water, so pure water. So we're not quite sure if there were pollutions or contaminants that may have actually pushed it under 1 for absorbance, or under 0 for absorbance. And the second one is all of these error ranges fall in the error range of the actual machine. So it may have been machine error or water error. We have not looked into how it would affect the salinity of the ocean water because we don't know how it would affect the salt water. We mostly use this experiment to focus on how we can work with zinc oxide instead of salinity. Okay, so our question was how we would do the application, and that was mentioned on our future direction slide. We would build these into like boats or something, and people could go around adding a little bit of zeolite on large scale basis. We have not given much thought to this, but that is our rough idea. No, we were not.
Could you comment on how you could get the size of those particles and how you think the size of the particle would affect it?
The only idea for her question was how we could figure out the size of the zinc oxide particles and how that would affect the system. My only idea about how we could measure the zinc oxide is using scanning electron microscope or something with a scale, and then we could just figure that out. And how it would affect is it would probably work with the zeolite and membrane filter, because if the zinc oxide is too big for the zeolite, it will not filter correctly. Anyone have any other ideas of how that would work?
Do you know if there are any other types of zeolites or any other material that does have a larger pore size that could accommodate?
We did not look into different materials. We were going with what we've used in the previous week. So we did not look into previous materials, but that could be a future direction. We have not actually, her question was if there is a way to bind the zinc oxide and make it harmless. We have not looked into that just yet. That is a good idea and possibly a future direction. I'm not quite sure. We did not actually reuse any of the zinc or the zeolite filter. That would actually be a really interesting way to do an experiment. Anything else? Well, thank you.